The topic of discussion is about security attacks, mechanisms, and services. Before going to know about security attacks, we must know about security goals. There are mainly three security goals. They are confidentiality, integrity, and availability. Coming to confidentiality is probably the most common aspect of information security. We need to protect our confidential information. An organization needs to guard against those malicious actions that endanger the confidentiality of its information. For example, in the military, concealment of sensitive information is the major concern. In banking, customers' accounts need to be kept secret. Data integrity. Information needs to be changed constantly in a bank. When a customer deposits or withdraws money, the balance of her account needs to be changed. Integrity means that changes need to be done only by the authorized entities or through authorized mechanisms. Availability. The information created and sorted by an organization need to be available to authorized entities. Information need to be constantly changed, which means it must be accessible to authorized entities. The unavailability of information is just as harmful for an organization as the lack of confidentiality or integrity. Imagine what would happen to a bank if the customer could not access their accounts for transaction. Coming to security attacks, our three goals of security, confidentiality, integrity, and availability can be threatened by security attacks. Attacks threatening confidentiality. In general, there are two types of attacks. They are active attacks and passive attacks. Attacks done on the confidentiality of the data are known as passive attacks, and attacks done on the integrity and availability of data are known as active attacks. Passive attacks. In passive attacks, there are two types of attacks: snooping the data and traffic analysis. Snooping means it refers to an unauthorized access to or an interception of the data. For example, a file transferred through the internet may contain confidential information. An unauthorized entity may intercept the transmission and use the contents for her own benefit. To prevent snooping, the data can be made non intelligible to the interceptor by using encipherment technique. And coming to the next attack, traffic analysis. Although encipherment of data make it non-intelligible for the interceptor, she can obtain some other type of information by monitoring online traffic. For example, she can find the electronic address, such as email address, of the sender to receiver. She can collect pair of requests and response to help her guess the nature of transaction. Coming to active attacks, modification of data. After intercepting or accessing information, the attacker modifies the information to make it beneficial to herself. For example, a customer sends a message to a bank to do some transactions. The attacker intercepts the message and changes the type of transaction to benefit herself. Masquerading. Masquerading or spoofing happens when the attacker impersonates somebody else. For example, an attacker might steal the bank card and pin of the bank customer and pretended that she is that customer. Replaying is another attack which obtains the copy of message sent by a user and later tries to replay it. For example, a person sends a request to her bank to ask for payment to the attacker who has done a job for her. The attacker intercepts the message and sends it again to the receiver another payment for the bank. Denial of server. Denial of server is a very common attack. It may slowly down or totally interrupt the service of a system. The attacker can use several strategies to achieve this. She might send so many bogus requests to a server that the server crashes because of a heavy load. The attacker might intercept and delete a server response to a client, making the client to believe that the server is not responding. The attacker may also intercept requests from the client, causing the clients to send requests many times and overload the system. Convolutional encryption principles. An encryption scheme has mainly five ingredients. They are plain text, encryption algorithm, secret key, ciphertext, and decryption algorithm. Here, plain text means user understandable language. Plain text is the original intelligible message or data that is fed into the algorithms as input. Encryption algorithm. The encryption algorithm performs various substitutions and transformations on the plain text to convert into cipher text. Secret key. The secret key is also input to the encryption algorithm. The key is a value independent of the plain text. Ciphertext. This is the scrambled message produced as output. It depends on the plain text and the secret key. Decryption algorithm. This is essentially the encryption algorithm run in reverse. It takes the ciphertext and secret key as the input and produces the original plain text. Cryptography is basically classified as three independent dimensional. The type of operations used for transforming plain text to ciphertext. The number of keys used: symmetric single key, asymmetric two keys, or public key encryption. There are many services and mechanisms in cryptographic network security. The International Telecommunication Union and Telecommunication Standardization Sector provide some security services and some mechanisms to implement those services. They are data confidentiality, data integrity, authentication of data, non-repudiation of data, and access control. Same as well, there are some security mechanisms which are encipherment, data integrity, digital signature, authentication exchange, traffic padding, routing control, notarization, and access control. There is some relation between services and mechanisms. Data confidentiality is an encipherment and routing control mechanism. Data integrity is an encipherment, digital signature, and data integrity mechanism. Authentication is an encipherment, digital signature, and authentication exchange mechanisms. The symmetric encryption is classified as classical cipher, is a type of cipher which we used historical but for the most part has fallen into disuse. In contrast to modern cryptography algorithms, most classical ciphers can be particularly computed and solved by hand. They are substitution cipher techniques and transposition cipher technique. The best example for substitution cipher technique is Caesar cipher technique, and best example for transposition cipher technique is rail fence and row transposition ciphers. In this in these techniques, we uses only single key for encryption and decryption, which is called a single shared key. Cryptanalysis. Cryptanalysis is the study of methods for obtaining the meaning of encrypted information without access to the secret information that is typically required to do so. Typically, this involves knowing how the system works and find a secret key. Cryptanalysis is also referred to as code breaking or cracking the code. The ciphertext is generally the earliest part of a crypto system to obtain, and therefore it is an important part of cryptanalysis. Depending upon what information is available and what type of cipher is being analyzed, cryptanalysis can follow one or more attacks models to crack a cipher. Historical cipher. Historical pen and paper ciphers used in the past are sometimes known as classical ciphers. Stenography. Although this bo- Although stenography is a technique for implementing security mechanisms, the word stenography is origin in a Greek means from Greek language it means covered writing. In contrast with cryptography, which means secret writing, cryptography means controlling the contents of a message by unciphering. Stenography means controlling the message itself by covering it with someone else.